All right. Hello, everyone. I'm going to get started. Just to set expectations up front here, this will be an introduction to what's new in RxJava 2, kind of what's new, why it's changed, and hopefully through that it will reveal the motivations as to why some of these changes were made and therefore motivate you to update. We will not be going over what RxJava is, why you would use it, so I expect some cursory knowledge already. Otherwise, you'll probably not understand any of this. But yeah, definitely check out, if you're not familiar with RxJava, you'll want to see another talk before seeing this one. So let's get started. The first thing about RxJava 2 is really about Reactive Streams, and this started a while ago. It's about 1.5 years ago now. Reactive Streams is an effort to provide a standard for these streaming libraries on the JVM. And the reason that we would want to do this is to allow them to interop with each other. So you're not always going to be interacting with libraries that build on RxJava. There are other streaming libraries, other reactive libraries, and the idea here is to create a standard so that when you encounter multiple in your application, translating between them and composing them together is trivial, and they both behave in the same way. So RxJava 2 natively supports this, and I'm going to show you kind of what the specification actually is. It's really just 4 interfaces and about, I think, 8 methods. The first one is called a publisher, and this is basically just a definition of something that can produce events. It could be synchronous, could be asynchronous, but it's a source of events. And the first thing to notice here, if you're familiar with RxJava, is in RxJava 1, when we subscribe, we used to get back a subscription, and this interface for a publisher actually declares void as its return type. So we're no longer getting back a subscription, and we'll kind of go into what that actually means. However, it takes a subscriber, and our subscriber type is similar to, it's actually exactly the same as what you already know in RxJava 1, with an exception of an additional method. And here's where we find our subscription. And so, again, we're going to kind of go into why this changed and what it actually means for your code. But the idea is that we're no longer returned a subscription when we subscribe. We actually have to supply a subscription. Subscription, exactly the same as it is in RxJava 1. We have a mechanism of canceling from listening to a stream. And then if you're familiar with how backpressure works, the request method is how you apply backpressure to the upstream, which is to slow it down and very explicitly tell it how fast you want events to be emitted. And finally, we have a processor, which is just an empty interface that combines both the subscriber and publisher. This is what we traditionally call a subject in RxJava 1. And so most of these shouldn't feel unfamiliar. It's basically how we interact with observables in RxJava 1. But this Reactive Streams is a specification. It's the set of interfaces as a dependency that RxJava 2 now depends on and implements, as well as other stream libraries available on the JVM. RxJava 1 actually has had an adapter for these Reactive Streams types ever since the Reactive Streams specification was released. And so if you may have already known that this existed, but this allows you to actually use RxJava 1 in a way that's compatible with Reactive Streams. Okay, there's some subtle differences that are defined in the specification that are really worth calling out because they're fundamental to potentially how you use streams now, and that will actually have to change with RxJava 2. The first one is that the specification defines that any of these callbacks on the subscriber are no longer allowed to throw an exception. They must return normally. So this means when you receive an onNext callback with a piece of data, when you're processing that data or forwarding it to something downstream, you're no longer allowed to throw an exception. It has to always complete normally. There's actually this is important just for mostly interop, but there's actually a wrapper around a subscriber that still allows you to throw an exception, and it will trap that and forward it to on error automatically. Usually this isn't going to be a problem because RxJava will handle most of that wrapper will handle most of it for you. The actual one that's going to cause a lot of problems is that this also defines that you can throw an exception, which is a null pointer exception, and you're supposed to do that when the value passed to this method is null. And so that kind of makes sense. We usually want to validate that parameters coming in are not null, except for the fact that there's this onNext callback. And onNext is the data flowing through the stream. And what this means is that null is no longer allowed inside a stream. You can no longer emit null as a value and have it flow down the stream normally. It will actually eagerly stop and break and crash your app. This winds up being a good thing because Java has no way to represent nullability in the type system. And so now when you're using any stream, you can always assume that it's the values being passed in are never null. And if we're using null to emit values as like just kind of a throwaway indicator that an event happened, like a click on a view, you'll want to use either just like an object or any other throwaway type that doesn't really matter. OK, so let's start looking at, that was Reactive Streams, which is the separate library that RxJava 2 implements. And let's start looking at the types in RxJava 2 which actually implement those interfaces. The first one is called flowable. It is an all-new type. And this is our implementation of publisher. So this is the type that can be a source of events. It also is subscribed to with the Reactive Streams subscriber. And you'll see why I'm calling these out explicitly in a second here. Similar to Observable in RxJava 1, you can emit 0 items, 1 item, many items, and it has 2 terminal events, which are either completes or it errors. It handles backpressure using that subscription object. And Flowable actually has hundreds of convenience operators to allow you to transform the stream, map it, flat map it, all the operators you're familiar with. So if we look at this list again, it's a source of events. You subscribe to it with a subscriber, 0 to many items, completes or errors, has backpressure, and has hundreds of operators that allow you to compose data. This is not a new type. This is basically just RxJava 1's observable. The reason it has a new name is because there's actually a new type called observable, which will surely lead to some fun code reviews and confusion. But flowable is the backpressure aware type, which basically has all the semantics that you're used to in RxJava 1's observable. We have another type called flowable processor, which is actually all new. And this is the implementation of processor from Reactive Streams. So it's a publisher and a subscriber, which means that you can subscribe to it for events, and you can also use it as a sink for events. And this is perfect for multicasting and adapting non-Rx code into Rx code. Except, wait a minute, this is actually just a subject. So we have these new names, and again, the reason is that there's actually a brand new type called a subject, which is new. The semantics of which are subtly different, but they have an important characteristic that's different. So both flowable and flowable processor are essentially observable and essentially subject. They have backpressure, many items. So what are observable and subject then? If flowable and flowable processor are the types we know, what are these new types that now have the same name? And what are their differences? So it's very close to being the same thing. The key differences are that unlike flowable, which you subscribe to with a subscriber, which is a Reactive Streams type, you actually use a different interface to subscribe to observable. It's called an observer, similar to one. It has the same semantics, same operators, number of items, completes or errors. But the most important one is that there's actually no backpressure support whatsoever. These are completely unbounded streams. You have no way of slowing them down. Subject, very similar. It's the exact same thing where it implements observable and implements observer. But again, because this extends from observable, your subjects now no longer have backpressure. Subjects themselves, the backpressure story was always really weak in RxJava 1 because you you don't know who's dumping data into the subject, so you can't really apply backpressure to them. But this basically makes it so that even if it makes it impossible to apply backpressure to a subject. And so why do we need this distinction? Why is RxJava 2 suddenly separating the concept of types that have backpressure and types that don't have backpressure? Backpressure itself was not actually in the original RxJava implementation. It came around the 19th minor version before it was 1.0, so 0.19, I think. So it was added late. It was kind of retrofitted into the design, which was initially created without the concept of backpressure. So it ended up working out really well and fitting in the API well. But because it came in so late, there are optimizations to be made in the type system that would have helped us out. So not all types actually respect backpressure in RxJava 1. And if you use RxJava, I'm sure you've seen crashes with missing backpressure exception. Even some of the built-in factories for creating observables in the early releases of RxJava 1 themselves didn't support backpressure. So you were using the built-in types, not even creating your own, and you would still have to deal with the fact that backpressure was missing. But the real reason is that backpressure is something that you have to explicitly design for. It's not something that you can kind of just retrofit into the system and expect everything to work. We kind of got lucky in RxJava 1 that it works as well as it does, but when you really step back and design the types and design the APIs around it, you wind up with a much better system. And so this is the reason why we have two different types. So we're elevating the concept of backpressure into the type system. So I'm going to show an example of why this is important. In Android, we have to deal with user input. User input is something that you really can't apply backpressure to, or at least you can't do it through the normal backpressure means of the stream. It's usually something that you want to do out of band, which means like disabling a button or changing the UI in some way that the user stops interacting with it. And so a model of this would be dragging your finger across the screen and having the points be drawn and interpolated into a curve. Contrast that with something like a database query where we're fetching rows from the database. This is something that you can apply backpressure to. You can say, I actually only want 10 items to start with, and the query actually can say, okay, well, I'll just do the first 10 items. And if you later request more, it can pick up the cursor where it left off and fetch more items. With RxJava 1, both of these observables were represented with the same type. So how do you know when you're building this or potentially composing them together? Well, I don't know why you would compose touches with a database query. If you're composing them together, how do you know that they both support backpressure properly, or that they're both don't have any backpressure at all? And the answer is you don't, and you wind up getting a missing backpressure exception with the type on the left, and the type on the right silently supports it. And so this is the reason that in RxJava 2, we now model these using different types. And so you actually cannot compose these two things together without taking the backpressure semantics into account. You cannot subscribe to the touch stream and try to apply backpressure to it. The type system and the API just simply does not let you do that. And the way that this works is that we have those two different interfaces. This is why I call them out explicitly. So the one on the left, which does not respect backpressure, does not support backpressure, we subscribe to with we subscribe to with an observer, and that observer passes in something called a disposable. And the one on the right we subscribe to with a subscriber, and that passes in a subscription. Disposable is very simple to subscription. It's basically just something that you can call a method on, and it cleans itself up. And subscription is the exact same thing, except for the fact that it has a method for backpressure. And so this is the manifestation of how this works in the type system. You have to use different types because one supports a feature and one does not support a feature. But you may be saying, like, well, what if I do need to compose them in some way? What if I do need to compose backpressure ignorant types and backpressure aware types? And there's, of course, a way to do that. But the advantage is because they're different types, you're forced to think about it. You're forced to make decisions at that composition point about how you want it to behave if backpressure were to happen. So here's what that looks like. Say we start with our observable, and it's our observable of touch events that are coming in as fast as the input system can handle them. For whatever reason, you want to compose this into something that needs to support backpressure. The method to do that is just toFlowable, except it requires an argument be supplied to it, and that's the strategy that you want to happen when backpressure is applied. So there's 3 options here. The first one's called drop, which basically says if events are coming in faster than I can consume them, just ignore the events. So what you would see here is Flowable would start off saying, give me 5 events. The first 5 events come in, they get forwarded, and then your finger keeps moving, but the Flowable hasn't requested any more events, so they get dropped. If later it requests more events, nothing immediately happens, except when more events come in, and then it sees 2 more. The other strategy, there's 2 more. The next strategy is latest, and so this is basically a cache of the most recent event to be emitted whenever you request more. So first 5 events, then we have some come in that we can't handle. And what latest is going to do is actually going to keep track of the most recent one that it's seen, so that when you do ultimately request more events, that one is the most recent one is immediately emitted, and then you get however many are left that you requested. And finally, buffer. Buffer, instead of just tracking the latest one, keeps track of all the ones that it has seen. And so if you request more after additional events have happened, you see them as they come. So 6, 7, 8 happens, and we're not ready to see them downstream. But then when we request 2 more, we immediately see 6 and 7, which were the 2 most recent buffered events, and then 8 is still in the buffer. And if more events come in, those also get added to the buffer in case you later request items. And so that's it. Those are the 3 ways that you can apply a strategy to convert into the backpressure world. And the key here, even if you don't, kind of didn't get this, it'll become more apparent when you actually start using it. But the key is that you have been forced to make this decision instead of either the decision being made for you or it just being silently not supported and ultimately will crash at runtime. It's moved into the type system so that validation of this has moved to compile time, and your app actually won't compile if you change you change an observable into a flowable. Your app actually won't compile and you'll have to make decisions. Or if you do the opposite, your app also won't compile and you'll have to make these decisions. Pushing validation to compile time. So it's kind of a confusing concept since backpressure itself can be a little confusing. I think on Android we'll probably favor the observable world, the backpressure-free world most of the time. But when you do have to move or interact with something that does have backpressure, at least now you're forced to think about it and forced to figure it out, rather than it just being something that happens when you release your app into the wild. The reverse is also possible. You can go from a type that's a flowable to observable. Here you don't have to do anything. You just call to observable. Because observable doesn't have backpressure, it basically just opens the faucet and lets all the events stream out as fast as they can come in. Okay, so those are the 2 big types. Those are the one, observable is the big one in RxJava 1 that everyone knows. And so observable and flowable are going to be kind of the types that you extract the most utility from and the types that you see represented and used the most. But there's also specialized types which represent subsets of the observable contract. The first one is single. We have single in RxJava 1. It either succeeds with a single item, hence the name, or it produces an error. Unlike RxJava 1, it does not have backpressure, and it has a bunch of convenience methods. The way to think about this is it's like a scalar value that's just asynchronous. So it's models just a single item. So you know that you will never get 2 items, and you even know that you'll never get 0 items. It's also similar, if you know JavaScript, it's kind of similar to a promise where you're guaranteed an item or failure. Completable, something we also have in RxJava 1, has no items. It either completes successfully or it errors. Also no backpressure support in RxJava 2, although it does have backpressure in RxJava 1. Again, you get convenience methods for transforming these types. This is more like a reactive runnable. It's a piece of code that runs and it either completes successfully or it fails. So we have those in RxJava 1. In RxJava 2, we get a third specialized type. This is called maybe. And it is actually all new. Promise this one won't be crossed out. This either succeeds with an item, or it completes without an item, or it fails. So the way to think of this is it's kind of like an optional, but it's a reactive optional. So an optional can be present or absent, and then there's also exceptions that can be thrown. And so this is basically the reactive form of that. It's either absent, it has no value, it has a single value, or it's representative of an exception, an error. And we'll see why actually all three of these types are useful, but we'll see why a third type had to be introduced and what it actually is useful for. Okay, so these are our three specializations. I'm actually going to skip this. Don't look. So this is like our chart of what type to pick. You have backpressure, you have no backpressure. And that's a pretty fundamental thing that you'll kind of know right away. In Android, a lot of the times we probably won't need backpressure. Things that are coming from the UI shouldn't have backpressure. You should slow them down or disable them using the normal UI mechanisms. Once you get into picking backpressure and no backpressure, it's really just about modeling how much data is going to be available. It will either be a single thing, maybe no data, just kind of an action that you want to run, or it will be a full-on stream that has, an unknown number of items, or at least more than one. Okay, let's look at why those three types exist and how they're used. So in RxJava 1, there's tons of methods, tons of operators they're called, on Observable that allow you to transform them in some way. And so one, for example, is the first operator. This returns an observable, and its behavior is that it just takes the first item that's emitted and then immediately completes. The problem is that in RxJava 1, once you've called that first operator, you're given back an observable. And what you don't know, or at least what's implicit about that observable, is that it's only ever going to have a single item. But we're representing it as a type that can have no items, can have infinite items, or could have a single item. You don't know. And so that's the advantage of these specialized types. And in RxJava 2, these specialized types are actually utilized as return types of operators. So when you call this first operator in RxJava 2, you're given back a single, which in the type system guarantees that you're only going to receive a single item. So now we get similar behavior, except because it's a single, by receiving an item that is a terminal event. And if it was a stream that was erroring, if this was a stream that was empty, you would actually get an error because you said you wanted the first item and there was no first item. So an empty stream might be something that you think is not error-worthy. And this is exactly where the optional type, the maybe type, comes into account. So by calling a first element method, you're basically saying, I want to request the first element. I don't want to be guaranteed the first element. And so now when you have an empty stream, the maybe type can represent this optionality of the item. And so your maybe type would complete with no item instead of representing an error. Similarly, other operators will return the other specialized types. So there's an ignore elements operator in RxJava 1. You just get back an observable that never emits items. In RxJava 2, that turns into a completable. And so now you know in the type system that you have something which represents just an action and never has any data inside of it. So it waits until the parent stream completes, and then all it does is itself complete. And so these aren't specific to the backpressure free world. They also exist on flowable. So ignore elements behaves the same way. You get back a completable. First element on flowable, you get back a maybe. And our first, which is the guaranteed item, you get back a single. So there's a lot of these methods to kind of convert between the different items. This is just a chart. You don't really have to kind of look through it. But in the upper right-hand corner, you get the narrowing operators. So these take a type that describes a lot of information and narrows it down into a type that describes less information. So going from an observable and calling the, the count. You want to count how many items. Well, a count is just itself a single value, and so you get back a single. Similarly, the bottom left is a widening operator. Because the higher up types can all represent the types that are down below, you can trivially turn a single into an observable of only one item. Okay, that wasn't supposed to go. Doesn't matter. RxJava 2 has basically all the same factories for creating these types that you've come to know in RxJava 1. So you have the just method for scalar values. You have you can pass it a list. You can convert a future. But the important ones, there's two kind of fundamental ones that have maximum utility when wrapping non-reactive behaviors. The first one's from callable. From callable actually made its way into RxJava 1 as well. And so if you haven't seen that, I would highly suggest looking at it. It's a way to wrap something that's synchronous inside of an observable and turn it into being lazy as well. So when I create this observable that delegates to some hypothetical getName method, it's not going to call that getName method right away. It's going to wait until you subscribe to it, and it's going to call it for every single subscriber. The advantage of this over other ways of deferring work is that a callable's method actually allows you to throw an exception, and so you can call something that throws a checked exception, like IO exception or whatever, and from callable will take care of automatically turning that into an on-error notification. Super useful if you're doing stuff like wrapping an HTTP request, which might fail with an IO exception. And so there's from callables available on every single type, and then there's similar ones called from action and from runnable, which are available on maybe and completable. And those don't have a return value. It's basically the idea of encapsulating just some work that you want to be done, turning it into a lazy stream type, and then whenever you subscribe to that stream type, it's going to run that runnable. In action, the difference between runnable and action is that runnable actually doesn't allow you to throw a checked exception. And so if you're doing something like writing to a file system, you might get an IO exception. Action is basically just a runnable that declares that whose method allows you to throw a checked exception. Okay. How many people call observable.create to create observables in RxJava 1? Shame on you all. You should never use this method. Never in RxJava 1, ever. Like, literally never use it. Thankfully, in RxJava 2, the create method is 100% less awful. It is actually one of the most useful methods in RxJava 2 and for creating observables. So this is now safe to use only in 2.0. And so basically what happened, if you're aware of the from emitter, which used to be called from async method in RxJava 1, its semantics are now what create is. And it's basically this. It's a callback that allows you to just dump data into the stream. You can use, you get a callback whenever someone subscribes, and you're given this emitter object. And then in the emitter object, you can just dump data. So in this case, we're sending a hello item, and then completing the stream. The unsubscribe, this type actually represents the callback, so it will be called for every single subscriber. And then the emitter is the sink. It's what forwards to the downstream subscriber. So this is where you dump all your data. And you can do this with, it's a lot of, so I'm making it a lambda. You could do this, with a single item. You could do multiple items. You can do no items. You can do errors. And these are all synchronous. So when you subscribe, it's going to emit these synchronously. But the advantage of this method is that you can actually wrap asynchronous sources. So if we go back to the HTTP request that we had wrapped in from callable, we can also use this create method and allow the HTTP client to execute the request asynchronously. And then whenever it's done, whenever it gets a response, we just forward that to who's ever listening. So on response, we get the body, send it, and then complete. And if our request fails, we just pass it to on air. The other advantage of this method is that it allows you to also trivially hook up an action to run when someone unsubscribes. So because this request is now asynchronous, the user might press back and not want to wait. Maybe they're on the subway in New York where there's no data connection. And so what we want to do is actually cancel this request when that happens so that we're not wasting resources. The emitter has a method called setCancellation, which is just a callback to run whenever unsubscription happens. And so in, 9 lines of code, we've wrapped an asynchronous source and turned it into an observable, and it's correct. It will behave correctly, unlike what it would be if we did this in RxJava 1. Also super useful on Android for wrapping UI events. Basically, every UI event is a callback of some sort, and you had to rely on libraries unless you want to write a lot of code, you had to rely on libraries kind of to wrap these for you, and so now it becomes trivial to do yourself. You create a cancel action, which clears a listener, and then you add a listener, which just dumps events into the stream. These exist on more than just Observable, so you can get an emitter for any of these types. And what's interesting is that you actually get different emitter types based on what the type you're creating is. So for completable, you're not allowed to call onNext. It doesn't have an onNext method because completable doesn't allow items. Similar to single, doesn't have an onComplete method. You can either call onSuccess or onError. The other side to look at is how you subscribe to observables. And so I touched twice now on the fact that these have different interfaces, and that's for moving backpressure into the type system. So does that adversely affect our code, which is at the leaves of the streams that actually has to subscribe and deal with these resources and unsubscribing? Because this type is similar to what we have in RxJava 1, but it now has this fourth callback with these new objects. So when we subscribe, do we have to do something with that fourth callback? What do we put in there? The answer is no. You essentially never want to use observer or subscriber. What you do want to use are two other types that are built in called disposable observer or disposable subscriber. These take care of implementing that fourth callback, which is essentially what replaces the subscription from RxJava 1. But we have a problem here. We have no way to unsubscribe from this stream. And so if you remember, I said disposable is basically the way that we unsubscribe now. And so one way to do this would be to hold on to your observer type. Hold on to your observer type, and then later, when you're done with the stream, you can call dispose on that observer, and it will walk its way up the stream unsubscribing. There's actually, you're probably not going to want to do that either. There's a convenience method that was added called subscribe with. And this is basically saying, I want to subscribe, but I'm subscribing with something that is itself disposable. And it starts looking like RxJava 1 a lot more, where you're given back this essentially like a representation of the subscription, which is now called disposable, that you can hold on to and later use as a way to unsubscribe. So basically the exact same semantics as RxJava 1. We now just have slightly different names. There's a composite disposable for fans of composite subscription. Same exact semantics. You add it it basically behaves like a list. And then when you're done, you tell it to dispose all of the ones in the list. So this is true for all 4 of the backpressure free types. And like I said, there's also a disposable subscriber, which also behaves in the same way. And so even though this is a completely different type, really all you care about is the fact that these all are disposable callbacks, and that these methods all return a disposable object, which, again, you can think of like the subscription type. OK. RxJava has releases in 2.0. So the RC3 was released a couple weeks ago or a week ago. These are actually more like developer previews, not release candidates. There are breaking changes in every single one. The next 2 are scheduled for, like a week, essentially, and then 3.5, 4 weeks. And then that's it. In about a month, we get RxJava 2 final. So, if you're not really interested in kind of how the library works or opinionated about its operators, just wait a month and you get the final release. But time's running out if you have any opinions or want to potentially influence the things that are going into RxJava 2. So bear that in mind. The package name is different. Doesn't really matter. So it's now io.reactivex. The Maven coordinates are different, the dependency coordinates. It's io.reactivex, RxJava 2, and then the artifact is still called RxJava. If you want to know why both these things have to change, I wrote a blog post about all the motivations behind allowing libraries to interop with each other and exist at the same time. So basically the whole point is that you can still run RxJava 1 next to RxJava 2 inside the same app. There are different package names, different Maven coordinates, so they'll be resolved differently, and Java sees them as different types. This is Android, after all. RxAndroid has been tracking the changes, and so there is a RC1 of RxAndroid. If you're not familiar, it basically just tells RxJava what the main thread is. It also has different package name. It also has different Maven coordinates, so you can still be using RxAndroid 2 alongside RxAndroid 1. But this isn't going to be like an overnight thing. We're not all going to send one big pull request to migrate all our apps from 1 to 2. There's libraries that create and emit observables, quite a few of them, and likely you have more than one inside your app. And so because these can coexist in the same app, we should have a way to allow them to live side by side. And so there's actually a library which basically will do the somewhat trivial but boilerplate written conversion between the two types. And so this essentially allows you to have both living together and have it not be horribly painful. So you can have a library that's built on RxJava 1, and you can start using it, that's built on RxJava 1, and you can start using RxJava 2 and just use these static converters to change that one library's types into RxJava 2's types. And if you want to do the opposite converters are still there. So this had a release just yesterday with all these methods. So this is basically what you're going to get. For other libraries that we're in control of, where we is Square, Retrofit 2 has a standalone adapter, so you can actually start using RxJava 2 inside your retrofit interfaces. And then all these other libraries, we're basically just waiting until we're waiting for a month. And then they will all probably be updated, and it's likely that we'll just stop updating the RxJava 1 versions of them. And so you'll still be able to use them, and even if you want the newer versions, you can use that conversion library to adapt them back into RxJava 1 until you're able to upgrade. OK. I don't have time for this section, which is fine. I was going to skip it. So the kind of TLDR of this talk, RxJava 2 is Reactive Streams compliant. This is not going to be a big deal for Android, but it is a big deal for people using this on the server side, where there are multiple Reactive Streams libraries that are built into kind of foundational frameworks like Spring. Backpressure has moved into the type system. This will be important for Android because I suspect every RxJava user has multiple missing backpressure exception crashes in their crash reporting tool. So this should hopefully reduce that without introducing too much complexity. We have the maybe type. This probably will never make it to RxJava 1, but represents kind of a reactive optional. Create is finally usable. And everything else is basically the same. Like all the operators that you know and love or hate and despise are still there. They have the same names. They behave basically in the same way. And so if your composing of streams and your manipulating of streams is essentially going to be all the same. Probably doesn't have to change at all. What changes is the source of events, the observables, the creation, and the subscribing to streams, which is the observers and the disposable stuff. So you're just changing the leafs, not the middle part. And it's coming out in a month. So you can start using it now, or you can potentially wait for a month where the API will be locked in stone. And that's all I got. Thank you.